Hello, everyone, and we're glad you've joined us for this live webinar, Continuous Improvement in Sample Management, presented by Bill Lovatt, Jay Patel, and Zachary Kogler of Brooks Life Sciences. I'm Christy Jewell of LabRoots, and I'll be moderating this session. Today's educational web seminar is presented by LabRoots and is sponsored by Brooks Life Sciences. For more information on our sponsor, please visit brookslifesciences.com. Now, before we begin, I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them in the Ask a Question box and click Send. We will answer as many questions as we have time for at the end of the presentation. If you have any trouble seeing or hearing the presentation, click on the Support tab found at the top right of your presentation window, or report your problem by using the Ask a Question box. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of the presentation window and follow the process to obtain your credits. Lastly, at the end of this presentation, you will receive a survey, which we kindly ask you to complete. Your answers and suggestions will help improve our webinar program and are greatly appreciated. I now present today's speakers, Bill Lovatt, Director of BioBank Operations and Continuous Improvement, Jay Patel, Continuous Improvement Specialist, and Zachary Kogler, Continuous Improvement Specialist, all of Brooks Life Sciences. For a complete biography on our speakers, please visit the Biography tab at the top of your screen. Gentlemen, you may now begin your presentations.
Thanks, Christy. Hi, I'm Zach Kogler. I am currently a part of the Continuous Improvement team here at Brooks Life Sciences as a Continuous Improvement Specialist. I recently graduated from Purdue University with a Bachelor of Science in Industrial Engineering and a minor in Organizational Leadership and Supervision. While at Purdue, I gained a passion for lean methodology, and I earned my Green Belt Six Sigma certification, along with my 30-hour OSHA certification. After I graduated, I was hired on as an operations intern at Brooks Life Sciences, in which I worked very closely with Jay and Bill. Right now, I am currently a continuous improvement specialist underneath Bill.
Excellent. Thanks, Zach. So I'm Bill Lovatt. I've been with Brooks Life Sciences for about 3 years now. I have responsibility for the Indianapolis Biobank, which we like to call the Indy Biobank. And it's the largest of Brooks Life Sciences biobanks that we have. We have global biobanks all over the world, but this is the largest one. I'm an engineer by degree, got an electrical engineering degree from Vanderbilt University. I've been working for a very long time. 20 plus years of that experience has been in leadership and continuously using and having success with executing continuous improvement type projects. So I bring a wealth of experience to the organization and work very closely to mentor both Zach and Jay, who can take it off next.
Awesome. Thanks, Bill. As Bill mentioned, I am on the continuous improvement team at Brooks Life Sciences as well, working very closely with both Bill and Zach. I'm an IUPUI alumnus with a degree in health services management and a minor in policy studies. I've been with the organization for about 2 years now and been practicing lean for 3 years. And I'm very excited to share off my experiences with you all today.
Excellent. So one of the things we wanted to start off with was, what is Brooks Life Sciences all about? And we're really all about the sample. So as we, look at this particular slide and you see the life cycle of a sample throughout that, customers have it, you plan how you're going to get it, you collect it, transportation of it to wherever you want to store it, and that's really when our biobank comes into play. We process that sample into storage, know exactly where it's at. We make sure that we're protecting it, keeping it at the right temperature, stored with the right types of materials, etc. And then we pride ourselves on being able to retrieve those samples very quickly and provide them back to the customer if they need them for something, send them to a third-party location to be tested, or in a lot of cases just to get them disposed of and provide certificates that they have been disposed of. But as we look at this whole slide, and you would have seen this if you'd done anything else with Brooks, this is really what all of Brooks Life Sciences is about. But today we're going to really focus on those three areas which we say is our biobank. And most specifically, we're going to be talking about how we've utilized continuous improvement to improve how we do process, protect, and retrieve our customer sample. So Jay, with that, why don't you kick us off?
Sure. Thanks, Bill. So why don't we look into the principles of lean methodology and how it applies in biobank. And we look forward to your questions at the end of this presentation. Again, thank you very much for joining us today and your willingness to learn about continuous improvement in sample management. So let's get started. At its core, lean is all about identifying and eliminating waste. Now, we see waste everywhere, whether you're shopping at a local grocery store or registering a sample inside a biobank. And it's very normal for people to get used to or accept the status quo. So we want to ensure that you understand how these tools can help you overcome these tendencies. And with that being said, Zach, why don't you take this topic along a little bit further?
Sure. Thanks, Jay. So on the left side, you see value added. So steps within your process could be value added. These steps add something to your product or your service which the customer is willing to pay for. So value added steps adds value to the customer, and you gain most of your expending company resources from doing so. The opposite, so on the right side, is non-value added. These steps include waste. However, just because it's a non-value added process step, it doesn't mean it's a bad thing. Often we must perform these steps due to regulatory or compliance reasons. For example, here at Brooks, we must have radioactive backup storage units. These radioactive backup storage units are taking resources in order to be operational. However, we have to do so in order to be compliant. You want to minimize these steps as much as possible. Now, pure waste is no value or no required, it's no value added and it's not required. So this pretty much means that resources have been expended, delays have occurred, and customers are not willing to pay. This usually occurs when you have underutilization of the workforce or if you have unnecessary handoffs. These steps you want to completely eliminate from your processes. Now that you understand the different categories of waste, Jay will explain how to identify the types of waste.
Thanks, Zach. So let's get into it. I know everyone on the phone's thinking, how, right? How can you identify waste in your everyday processes? So when we talk about the 7 wastes of lean, they'll put some structure to this and help you understand the pure waste that Zach just described within your processes. So next we'll take a deep dive into each of the 7 wastes, and we'll all provide some examples in biobank settings and try and relate those back to everyone on the phone and some of the within our biobank list processes. So hopefully you find this beneficial, and with that being said, why don't we let Bill kick us off?
Well, before we jump into the details, let's have a little fun. So I want to introduce you to the most important person that's behind this whole lean methodology, named Tim Wood. Now, he's not really a person. He's just a way to remember the titles of the different types of waste in being an acronym. So transportation for the Tim and Tim Wood, etc. So just keep that in the back of your mind in a way to remember the ones, and now we're going to step through each of those particular things. So, Zach, why don't you tell us about the waste of transportation?
Sure, thanks, Bill. Waste of transportation is defined as unnecessary movement of people and material between processes. So often, an example of this would be moving sample shipments between buildings, or receiving shipments at one building while the processing is at another. And often, poor inventory stocking locations can also cause a waste in transportation. And Jay will talk a little bit about a waste in inventory.
Sure, thanks, Zach. Waste of inventory is basically everything raw material, everything that's work in progress, and even the finished goods that aren't really adding any value to you or your customer. So in other words, holding inventory, whether that's material or information, more than required. So I'll give you an example. The files and documents that we have to wait to be processed is a good example of the waste of inventory. Whether you overorder your consumables to support the sample management operations or the scheduling issues from the suppliers, they're all great examples of the waste of inventory. Now, Bill, why don't you walk us through the waste of motion?
Yeah, so when we speak about motion, we're really speaking about the movement of people, parts, or machines within a process. I want to stop there for a second to point out that word within, and then in comparison to the top of this slide where Zach was talking about transportation, and he talked about between. So it really is the key difference between transportation waste and motion waste is whether it's between processes or places, or whether it's within the process that you're doing. So as you think about the waste of motion inside of a biobank, it's walking throughout the facility. It is reaching to get materials, moving your hands around more than they need to be, readjusting scanners, things of this nature. But it can also be things like searching for files. So has anybody, when you go to do your taxes, ever spend a little bit of unnecessary time trying to find those documents that you got throughout the year? I know I sure have. So that's the kind of things that happen, and those happen in the biobank as well. If you have materials that you file away but you don't have a great filing system, you can take more time than's necessary moving around, motion, searching for things, looking for things. That also happens with inadequate layout of a workstation or not having supplies at your fingertips, having to walk across a building, or with a biobank and being in a area and being all gowned up. If your materials are sitting in the office space, you got to completely degowned and wash up and go grab your stuff and come back in. All of that would be considered excess motion or waste that's due to those motions. So with that, we'll move on to the next slide, and Zach, you'll pick up with the next waste.
So the next waste is waiting. Nobody likes to wait, neither do the employees. So anytime that a technician is waiting to be assigned a job or waiting on equipment maintenance to be completed, you are wasting time and resources. So in order to eliminate this waiting time, it's best to create a single piece flow or a more leveled workload, but being careful not to overproduce, which is our next waste.
Yeah. And speaking of overproduction, what kind of things would be overproduction for our kind of environments? And one of those would be printing documents out way in advance, and you print those out, and then then that leads to other waste, right? It's interesting how these things kind of interact with one another. So if you overproduce stuff, you're doing stuff too far in advance, you have the risk of losing it, that gets misplaced, more time being spent, or like we wrote up here on the board, printing more labels than you need means you're going to throw labels away. So you've not only wasted the time it took to print the label, but you wasted the actual resource of the label as well, and the ink and all the rest of it. So those are the things that happen when you choose to overproduce. And not lastly, but next we will have Jay talk about the act of overprocessing.
Sure, thanks, Bill. And I think the term itself gives itself up, right? The definition just being that you're doing more than what's required to meet your client's expectations. So this could be, too many approvals required to add a new project into your system, any additional quality control checks in your biobanking processes, that would require duplication of efforts. And this one might actually hit the home for those in this arena. When you are autoclaving, when you're incinerating the samples, when autoclave can be sufficient. Those are all good examples of overprocessing, the waste of overprocessing. So now, Zach, why don't you go over the last waste?
Thanks, Jay. So do it right the first time. That's a phrase that I'm sure most of you have heard before. So defects, they cause a waste in time, a waste in resources, and a waste in effort to try to create or correct the failure. Some of these examples would be retrieving the wrong sample or a data inaccuracy. It's important to focus on these common errors and redesign the process to reduce the number of defects. Definitely target those pain points. So now I'll pass it off to Bill to discuss how our business uses the knowledge of waste to improve the organization's layout.
Yeah, thanks, Zach. So, very interesting, when I started my leadership role here at Brooks Life Sciences in the BioBank, which was late 2016, one of the first things that I had as a challenge was, how do I increase the amount of processing and retrieval capacity that the organization had without increasing our physical space? So we have a sample administration area which has some walls around it and doors, and was really asked, you need to still do that work inside of that square footage. But we're growing as an organization, and growing at a pretty fast clip, and therefore need to be able to drive that extra capacity. So that really started off with observe what people are doing, observe the process. And one of the tools that you can use is called a spaghetti diagram. The spaghetti diagram is really nothing more than just on a piece of paper, which has a picture of your layout. Follow the process, walk the actual process, and draw on the paper what the operator is actually doing. And boy, did we have a pile of spaghetti. Could have been great to have some meatballs with that. But it's not unusual. It is what usually everybody finds whenever you walk really any processes. Jay had said in the very beginning, even if it's going to the grocery store, how many times did you walk down that center aisle instead of the one time that you should have gotten everything on your list from that aisle, especially if it's a new store. You're walking all over that crazy store. So, what we found was lots of waste from that, lots of waste of motion associated with that. But that's not all we found. As we really started to look at what was going on, we had a situation in which people were having to walk into the area, log into a computer at their workstation, get into our system that we use here for our biobank, get their work assignment, understand the location of where they're going to pick up their materials, and know what they need to do. Then they would log out of that computer, and they would walk outside to an area where we had some carts. And carts had these containers on them that we'll call from here on in our discussion WIPs, work in progress. It's the bin itself that we're talking about, not the actual work, when we're saying WIPs through this discussion. And an interesting thing is that, they went out there and got that. They'd log back into that computer so that they were doing real-time moves of their material. Then when we come back into the area, now they have to offload it. So I identified, which is a waste and a concern that we didn't really talk about before, and that's one that often will be called that eighth waste. And that's the eighth waste, is having kind of safety concerns and the loss that you can have from the business of having somebody get hurt. So we also found that the people were picking up these WIPs, and often these WIPs were quite heavy, and they were having to twist and put it on a stand. And then when they were done with their work, they were having to do that again. So we really, were able to, through utilizing that tool, the spaghetti diagram, and by observing and by really thinking about Tim Wood and taking Tim Wood's advice and looking at all the different types of waste, we were able to increase our workstation capacity in that space by 25%, and at the same time, simultaneously, we reduced excess motion, we reduced overprocessing, and we eliminated a lot of waiting that was going on. But probably the biggest thing that we did was eliminate that safety concern and really truly give our workers a better work environment. So with that discussion, I'm going to turn it over to Zach, which took on our kind of next journey that we did. Once we had that layout and we had the capacity we needed, we wanted to continue to improve that work environment for our employees. So Zach, why don't you talk about the project that you worked on next?
Sure. So the 5 S's, often referred to as 6 S's, it's a philosophy. And this philosophy focuses on organizing and managing the workplace by eliminating the 7 types of waste that we've been talking about today. And we eliminate these wastes while also improving quality, improving safety, and performance of the technician. So the primary 5 S's goes as follows. You can read it on the screen, but it's sort, set in order, shine, standardize, sustain. And then the 6th S I'll talk about later, which is safety. But this first step is sorting. So when you are sorting, you're identifying all of the items in the work area that is necessary. Employees are supposed to distinguish whether or not that item's needed. At Brooks, we have something called the red tag table. It's a great tool to use to separate valuable equipment and non-valuable equipment, or maybe equipment that's not necessarily being used at this time. And by scheduling periodic audits of this table, we're able to put items back that we know that the technicians need and we just need to find a better home for, or we just dispose or recycle of items that we no longer need. But after you've essentially sorted out this unnecessary tooling, you must set in order a standard, consistent way to store and retrieve necessary materials. So with each item being returned to the workplace immediately after use, you're pretty much successfully minimizing time spent searching for tools and equipment. A way we do this at Brooks is by color line marking certain processes or signage for equipment and supplying technicians with a shadow board. And what's very important to learn is that you have to clean the area, or as we say, shine, which is that next step there. And it's critical. It's absolutely critical for sustaining the 5S effort. Because workers are cleaning their area on a daily basis, equipment malfunctions and other issues can be easily identified. This will reduce wait times for equipment malfunction and other sorts of issues. So standardization can really only occur after the 3 other S's, so the sort, the set, and the shine. And to standardize, you're creating that set standard of responsibilities that the operator must follow daily. Of course, this must be periodically evaluated and to ensure that the individual is actually doing their job. We do this here at Brooks by an end of review sheet. The technician would look on the sheet at the end of the day and know exactly what to do. With each technician at the end of the day doing such said set standard process, we know when something goes wrong and we know how to fix it. So, like I said earlier, 5S only works if it's sustained and has everybody on it. So by sustaining 5S in the workplace, you're assigning employees a time to complete the task. You're also giving them a clean and comfortable work environment to be at, something that they want to come in every single day. Creating that reward system, maybe having a reward system for those who are supporting the 5S initiative. It always works. So it really is a monkey see, monkey do situation. And what I mean by that is upper level management. Participate in 5S activities. Embrace this philosophy, and your employees will follow. Lastly, Brooks, we consider safety as the 6S. And what Bill mentioned earlier, safety concerns can cause waste. And often these wastes come in many different forms. They come in delays, they come in damage, or even worse, injuries to your employee. So it's very important that you have the 6S and that you are following the regulations and regulatory standards. So not only can you eliminate waste within the work environment, but you can eliminate waste within your organization's core operational process. And Jay will speak on that now.
Thanks, Zach. As Zach mentioned, minimizing waste from the core ops processes, I think that this project really ties that concept in. And so we kicked off the DFRAC project earlier this year. The idea that we had was to assess the capacity of our biobank and really understand and eliminate the inefficiencies that are caused by inadequate storage of samples, right, within our storage boxes. So I'll walk you through the process. As you can see on top of your screen. A technician goes inside a freezer to retrieve the samples that are ordered by the client, whether to ship the samples back to them, do extra processing, whatever the reason might be, leaving empty spots within that tray or the storage box, and it goes back inside the freezer. For how long? You never know. Could be days, weeks, or years. So now that you have a little bit of background into this process, this project was aimed to minimize the underutilization of the storage boxes and really eliminate the inefficiencies associated with the retrieval process as well. So we did a lot of data analysis initially to understand how full our storage boxes are, and understood the limitations that were in place, especially the sizes of the samples and the type of material to stay within the boundaries. And our analysis really, as you can see it in the Pareto chart in the middle there, it showed that we had significant control over the backfilling process, and it was effective. But as you can see in the tail, we still had a little opportunity there to improve. So as we tie this whole project into the 7 wastes that we discussed earlier, the first one that really comes to mind is the waste of overproduction, as we're creating, the new storage boxes, and even the old boxes were underfilled. The second one is the waste of motion that Bill had went over earlier, that we began to add new freezers, which led us to a bigger footprint of the floor and for storage, causing excessive movement of people, equipment, as well as the material. And both of which also point to the third waste I'll outline now, is the waste of inventory, as we started to have excessive amount of storage boxes and new freezers were put into service that were adding zero to no value to the process itself. So we started noticing a few other benefits as part of this project. This effort really allowed us to delay the purchase of the new storage boxes and the capital equipment, such as ultra-low temperature freezers. We eliminated the additional freezer maintenance that was done by our facilities team locally, and we were also able to perform a quality control check on the freezers that had very low access. So speaking of the storage boxes, we have a very specific type of storage, and we had identified that our defect rate was higher than other sample types. So I'll let Zach get into the details of this improvement project.
Right. So thanks, Jay. As mentioned earlier, defects can cause waste by reprocessing and recorrecting that failure. So you can combat this type of waste by holding something that we call is a Kaizen event. This Kaizen event is made up of a cross-functional team of operators, technicians, managers, and you gather this perspective. You map the existing process, you discuss improvements and pain points that you may have within that process, and then you gain buy-in from all of the department. That's where the success will lead you. In our case, we held the Kaizen event over a slide box handling. So like I said, we mapped our current process, our handling process, and we found pain points. We also reviewed any documented errors that we had over slide handling issues. And the team came up with a few areas of improvement. Some of these improvements were space concerns, eliminating large subshelves, managing downstacking. So we brainstormed and tested solutions. And so what you see on the screen here are some of the solutions that we came up with. So that first solution is the physical and virtual grid system. The physical grid system that you see there on the left and the right holds different types of slide boxes. So the one on the left is a 1x25 slide box holder. The other one is a 1x100. Now, the physical grid system allows for sample integrity, quick retrieval, and it prevents overfilled bins. Now, the virtual grid system allows us to have capacity visibility without even physically checking to see if there's space or not space. Now, we've also eliminated the large subshelf and reduced that size of the bin and came out with and started using smaller bins. These smaller bins are less heavy and smaller in size. Once again, this is an ergonomical benefit to the technician, and it frees up other storage opportunities. You see there on the bottom left that we have a cart. This is a walking cart, and it encourages proper down stacking, which will lead us to the subshelf retrieval layout, as I also like to call it the slide handling area. This slide handling area is a dedicated location that supports and aids retrievals of storage of slide boxes. It perfectly fits our small bins and assists with the general workflow while requiring little to no down stacking, which was once again one of those major pain points. Lastly, being prepared for the unexpected. You're taking the initiative. So this means having any adequate containment is a must when dealing with nonconformities or found defects. So in conclusion, the Kaizen team did a great job, and the efforts focused on mitigating slide handling defects, reducing that waste in motion, and overall decreasing wait time. So I'll now have Bill close us out for today.
Excellent. Thanks, Zach. Great example. One of the things that probably was thinking right as you started, and I know I did as I've moved from industry to industry, it's always, if I'm not a traditional manufacturing environment, how's this lean thing going to work? And, you know, I hope that the explanation of the theory are examples of how those different principles do work within a biorepository, as well as the examples of what we did to improve our operation, put you in a position that you want to go through your Rolodex, for those of you who still have one, and your cell phone for most today, but get Tim Wood's number up, give him a call, take his advice, and identify the wastes that are going on within your business. Then yank out that toolkit. Yank out that toolkit of the knowledge of value add and non-value add, your spaghetti diagrams, your process mapping, 5S, utilization of Kaizen, and really at the end of the day, look everywhere that you can to reduce the waste, really focusing on minimizing things that are required, but make those things as easy as possible if they're not adding value to your customer, and try to truly eliminate those things that are pure waste. And we really hope that this helps you be in a position to be able to improve your operation, to hit whatever goal it is that you're trying to hit, but maintain the quality and safety of your environment while you're doing it. Thank you very much, and I look forward to your questions.
Thank you, gentlemen, for your presentation. So let's get started with our Q&A. Now, just a quick reminder to our audience on how to submit questions. Just click on that Ask a Question box located on the far left of your screen. And as a reminder, any questions that we are not able to get to today, Bill, Jay, and Zach will be answering them via email, so don't worry if we don't get to your question right away. All right, so our first question. How do you believe lean methodology and continuous improvement will affect your company 3 to 5 years down the road?
Thanks, Christy. This is Jay Patel. I can answer that question. I think that 3 to 5 years down the road, we expect that we accelerate our improvements, as by then we have built the infrastructure that allows changes at a faster pace, and a workforce that accepts those changes as well. And I guess another piece of that is agility. And through continuous improvement of our processes, we'll improve the agility to react to the new opportunities and changes in the marketplace more readily.
Thanks, Jay. Now, will you cover a system to track the material?
Yeah, this is Bill Lovatt. So here at Brooks Life Sciences, we do have a company proprietary inventory management system, which was specifically designed with sample management and specifically biological sample management as its core tenant.
Thanks, Bill. Now, what have you found unique about applying these manufacturing principles in a biobank environment?
Yeah, it's kind of an interesting one because although, it is unique, I personally have worked in a number of different industries, some of which were specifically manufacturing, which was what these tools and things are specifically aimed at. But as I've worked in different service industries, with this being one of delivering, biobank services to our customers, it even though there is uniqueness, you can always go back to, slides 8 and 9 went through each of the different wastes and gave the classical description, but then we gave an example or two of what worked within the biobank. The bottom line is that the general principles have always applied, and we've not really had issues in doing so.
Thanks again, Bill. Now, have you had any pushback from the workforce, and how have you handled that?
So that's a great question. To answer that is, we've encountered pushback, and really change is hard for anyone. So you will encounter employees who challenge ideas or have a difficult time adjusting to these new implementations. A way that we handle this at Brooks Life Sciences is we set clear expectations before implementing the change. And we also involve the employees in the development of that solution, so gaining their support, gaining their buy-in. You will often be able to use a quote that's remember, these were the solutions we agreed on, or these were the goals that we agreed on. You want to be using that to leverage yourself. And lastly, you want to get to know your employee so you understand what motivates them. And motivation is key in the workplace. So you do not always need to motivate your employees with money. You can motivate these employees by possibly creating a flexible schedule for them, or giving extra breaks, or maybe even providing a quieter office. Everybody has their own motivation to get things done. So that's a great question.
Yeah, and this is Bill Lovatt, and with that, I'd just like to thank everybody for listening in today and listening to our journey as we've been using continuous improvement to benefit our biobank, and ultimately for those that are customers on the line to better our service to you as customers. And lastly, it is continuous improvement. It is a journey, so we look forward to continuing to move forward, utilizing Lean over the next few years and extending to more advanced methods of continuous improvement as we improve upon our capability within our group. So thank you very much, everybody, and hope you have a great day.
Thank you, Bill, and thank you, Jay and Zach, for your time today and for your excellent presentation. I'd also like to thank LabRoots and our sponsor, Brooks Life Sciences, for underwriting today's educational webcast. Now, before we go, I also want to thank all of you for joining us today and for your great questions. As a reminder, those questions we did not have time for today and those submitted during the on-demand period will be addressed by our speakers via the contact information you provided at the time of registration. Now, a survey will pop up on your screen, and your participation is greatly appreciated. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. That's all for now, and we thank you for joining us. Have a great day.